The purpose of this lesson is to teach you how to predict the number of solutions there are in a quadratic equation by using the discriminant. The discriminant is a part of the quadratic formula that is b squared minus 4ac. By evaluating that part of the quadratic formula and finding a numeric answer, we're able to then use that answer to predict the number of solutions. Here's how. Step 1. You need to make sure your equation is in standard form. That may already be done when you start the problem, or may need to be done through manipulation by yourself. Step 2. Identify a, b, and c from that quadratic equation. Step 3. Substitute those values for a, b, and c into the b squared minus 4ac, and that will allow you to calculate the discriminant. Step 4. Simplify. Get to a numeric answer. 5. If b squared minus 4ac is greater than 0 or is positive, we can expect there to be two solutions. Visually, that would be this case, where our parabola has two zeros, or two x-intercepts, or two roots, whichever phrase you'd like to use. If when we do steps 1 through 4 and we get out a value of 0, if b squared minus 4ac is equal to 0, then we would only expect to find one solution. And that one solution would look visually like this case here in the middle, where the vertex touches the x-axis only, and there's just that one x-intercept, or one root, or one 0. In the third case, if we calculate steps 1 through 4, and we get a negative value, if b squared minus 4ac is less than 0, then we know there's no solution. There are no roots, no x-intercepts, no zeros. That would be this third graph over here where the parabola does not touch the x-axis. Let's walk through an example together so you can see this play out. Again, at the top, we start with the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant only uses this red part, b squared minus 4ac. And so what we need to do with this equation is not solve the equation. If we were trying to solve the equation, we would use the whole formula. Right now, I'm only helping you find the discriminant's value and using that value to make a prediction as to how many solutions we'll have. So, we follow our steps. Make sure the equation is in standard form. That's already done. Step 2, identify a, which is 5, b, which is negative 10, and c, which is 3. Next, substitute those values into the b squared minus 4ac. Remember, we're only dealing with b squared minus 4ac. So what we're going to do is substitute in the b value of negative 10 for b, minus 4 times the a value, which is 5, times the c value, which is 3. From here, we're going to simplify. Negative 10 times itself is positive 100. Minus 4 times 5, which is 20, times 3, which is 60. 100 minus 60 is 40. 40 is your discriminant's value. That number tells us something. Remember, if b squared minus 4ac is greater than 0, we know that we have two solutions. So we can confidently say there will be two solutions when solving this quadratic equation. Graphically, it would mean that the graph would have to touch the x-axis in two locations. Where, I'm not positive yet, but I know for certain there would be, in fact, two zeros or x-intercepts and roots. And I know that because the discriminant test told me so.